Simplify. So the first thing we're going to do here is perform some simplification within the brackets. We're going to use the quotient rule, which tells us that when we divide like bases, the exponent in the denominator can be subtracted from the exponent in the numerator. Then we'll also simplify 36 divided by 4 to be 9. So, like I said, 36 divided by 4 is 9. And then x cubed over x to the power of 5 can become x to the power of 3 minus 5, and we still have y to the power 8. Keep in mind that this is all still raised to the power 1/2. So we'll have 9 x to the power of -2 y to the power 8, all to the power of 1/2. And then we'll actually apply this 1/2 exponent. So we'll distribute it among the items that are being multiplied together. We'll have 9 to the power 1/2. Now we're going to employ another exponent law that tells us when we have something that's raised to a power that is then raised to another power, the two powers multiply together. So we'll have x to the power of -2 times 1/2 times y to the power of 8 times 1/2. We're going to convert this exponential form to radical form. Remember that when we do that, the numerator of the fractional exponent becomes the power on our radicand, which is going to be 9. We'll have 9 to the power 1, while the denominator of the fractional exponent is the index of our radical. So we'll be taking the square root of 9 to the power 1. In other words, 9 to the power of 1/2 is equal to the square root of 9. Now, -2 times 1/2 is -1, so we'll have x to the power -1, and 8 times 1/2 is 4, so we'll have y to the power 4. The square root of 9 is 3, so we'll have 3x to the -1, y to the positive 4, and we'll just finish up here. The negative in the exponent on the x variable means that we'll have to take the reciprocal of our x variable, so 1 over x, which basically means that the x variable will end up in the denominator of our final expression. So we'll have 3y to the power 4 over x to the power of +1, or in other words, just x. So this is the final answer for this problem.